So the HMI is a good example because there's already makers that are doing HMIs that are extremely nice. I mean, if you look at like how a tablet looks and you look at how like the animations that are within a tablet, those same type of technologies could be put into the manufacturing industry, and Allen Bradley's HMI should be able to have that level of animation and have that ability of control. However, they don't, right? And in my opinion, it's kind of unacceptable. I understand that like technology has grown quickly, but at this point now we've had, you know, tablet type of handheld devices for over 10 years now, and those tablets, you can actually run an HMI that communicates to a PLC right now, right? Like I personally have that capability to develop a HMI that can communicate over Wi-Fi to a PLC, and I can be able to cycle start a robot, right? However, it's not industry accepted, and it's not being developed by other people in the industry. And like the biggest reason why we're not shifting is like, oh, we use Allen Bradley HMIs, right? And however, there's other systems on the market that are actually becoming better than like the Allen Bradley HMI. Now, I'm not saying that Allen Bradley's not the way to go. Like we still use Allen Bradley PLCs on all of our systems, and we use Allen Bradley GuardLogix PLC in our systems. And you know, we utilize that every time, and we highly promote that PLC. Unless it's, you know, suggested by a customer, then we'll use other PLCs on the market. Now, what is the GuardLogix PLC? Since I brought that up, GuardLogix PLC gives you the ability to program in a safety environment. And when I say safety environment, the devices need to be safety rated in the manufacturing industry. And when something's safety rated, generally it has redundancies built into it. So if one thing fails, another is good. So maybe that's in the electrical engineering of the device, that maybe, let's say for instance, if you had a switch, like a light switch, right? That instead of that light switch just having, you know, 2 wires that pass through it, it would actually have 4 wires that pass through it, you know, so that way whenever that switch is activated, there's 2 signals that say it's on, there's 2 signals that say it's off, and if ever there's a mismatch between those 2 signals, then the system knows that there's a failure in the device. So in order for a system to be safety rated, you have to use safety rated devices, safety rated PLCs, and the safety programming has to be done in the safety portion of the safety PLC's code. So there's like a separate area where you program in your safety functions versus your standard logic. And if you don't do that, then technically let's say you're breaking the law, you're not abiding by the code for safety standards. I could probably go on about PLCs and controls engineering for hours and hours, so let me know some questions that you have, put them in the comments below. Hopefully I can get those questions answered for you, and we can kind of continue this conversation. I want to do more controls engineering type of videos. I started this channel out to help an engineer that was like stuck in a particular position, and now we're doing all kinds of stuff, right? We're talking about different manufacturing processes, how to navigate your career in the manufacturing space, how to automate particular processes, and doing videos like this as well. So make sure you subscribe if you're interested in any of those types of contents. And also we're talking about the Tesla robot, which is a pretty cool topic. But yeah, hopefully we'll see you in the next one.